Apollo lunar missions. Few achievements in human history come close to what the Apollo program accomplished. Between 1969 and 1972, NASA landed 12 human beings on the surface of the moon and brought them all back safely. Apollo 11 was the first, carrying Neil Armstrong and Buzz Aldrin to a flat plain called the Sea of Tranquility, while Michael Collins orbited above. Armstrong's first steps on the lunar surface were watched by an estimated 600 million people on Earth. The missions that followed went to increasingly difficult terrain, with later crews driving a lunar roving vehicle across the surface and collecting hundreds of kilograms of rock samples. Those samples are still being studied today and continue to reveal new information about how the moon and Earth formed. Apollo remains the only program in history to have placed humans on another world, and everything learned from it still shapes how deep space missions are planned. Voyager 1 and 2, deep space probes. When NASA launched the twin Voyager spacecraft in 1977, no one alive expected to still be receiving signals from them nearly 5 decades later. The two probes were designed to take advantage of a rare planetary alignment that allowed a single spacecraft to visit multiple outer planets, using each planet's gravity as a slingshot. Voyager 2 flew past Jupiter, Saturn, Uranus, and Neptune in sequence, returning the first detailed images of those worlds and their moons. Voyager 1 focused on Jupiter and Saturn before heading on a trajectory that would take it out of the solar system entirely. In 2012, Voyager 1 crossed into interstellar space, becoming the first human-made object to leave the sun's direct influence. It is now the most distant object ever launched by humanity. Both probes still transmit data, and scientists use that data to understand the environment beyond our solar system, a region no other spacecraft has ever reached: Hubble Space Telescope. Before Hubble, our view of the universe was limited by the distorting effect of Earth's atmosphere. When the telescope was placed into orbit in 1990, it changed astronomy permanently. Its images were sharper and deeper than anything ever captured from the ground. Hubble helped scientists measure the expansion rate of the universe with precision, provided strong evidence that supermassive black holes exist at the centers of most large galaxies, and photographed galaxies so distant that their light had traveled for billions of years before reaching the telescope's mirror. One of its most famous images, the Hubble Deep Field, pointed the telescope at a seemingly empty patch of sky and revealed thousands of galaxies in a region smaller than a grain of sand held at arm's length. Hubble has required servicing missions to repair and upgrade its instruments, but it continues to operate and produce groundbreaking science more than 30 years after launch. Mars Curiosity Rover. When Curiosity landed on Mars in August of 2012, it did so using a method so unusual that engineers called the final descent the 7 minutes of terror. A rocket-powered sky crane lowered the rover gently onto the surface using cables before flying away and crashing at a safe distance. Curiosity was sent to Gale Crater, a location chosen because it showed evidence of ancient water. In its first years of operation, the rover confirmed that Mars once had liquid water on its surface, and that the environment in Gale Crater was once suitable for microbial life, at least in terms of chemistry and temperature. Curiosity is the size of a small car and carries instruments capable of drilling into rock and analyzing the chemical composition of what it finds. It is still driving today, more than a decade after landing, climbing through the layers of Mount Sharp at the center of the crater, and reading the geological history of Mars, one rock layer at a time. Cassini-Huygens mission. Saturn is one of the most visually striking objects in the solar system. But before Cassini arrived, much of what we knew about it came from brief flybys. Cassini entered orbit around Saturn in 2004 and spent 13 years studying the planet, its rings, and its moons in extraordinary detail. It discovered that the moon Enceladus has a liquid water ocean beneath its icy surface, with geysers of water vapor venting into space through cracks near the South Pole. This discovery placed Enceladus among the most promising locations in the solar system to search for life. Cassini also carried the Huygens probe, built by the European Space Agency, which separated and descended through the thick atmosphere of Titan in January 2005. Huygens sent back images and data for over an hour as it fell through orange clouds and revealed lakes and river channels filled not with water but with liquid methane. In 2017, with its fuel nearly exhausted, Cassini was deliberately directed into Saturn's atmosphere to burn up, preventing any chance of contaminating the moons that might harbor life. DART Planetary Defense Mission. The Double Asteroid Redirection Test was the first mission ever designed to change the motion of a natural object in space. Its target was Dimorphos, a small moonlet orbiting a larger asteroid called Didymos, chosen because the pair posed no actual threat to Earth and could be safely used as a test. In September 2022, the DART spacecraft, roughly the size of a vending machine, collided with Dimorphos at approximately 22,000 kilometers per hour. Telescopes on Earth and in space watched closely. Before impact, Dimorphos completed one orbit around Didymos every 11 hours and 55 minutes. After impact, that period shortened by 32 minutes, well beyond what mission planners had set as the minimum for success. This was a proof of concept for a technology that humanity may genuinely need someday. The fact that it worked on the first attempt against a real asteroid in deep space was a significant moment in the long-term effort to protect Earth from potential future impacts. James Webb Space Telescope. The James Webb Space Telescope represents the most complex and expensive scientific instrument ever sent to space. It launched in December 2021 and reached its operating position roughly 1.5 million kilometers from Earth, a location called the second Lagrange point, where it remains in a stable orbit that keeps it shielded from the sun. Webb observes the universe in infrared light, which allows it to see through clouds of dust that block visible light and to detect light from objects so distant and so old that the expansion of the universe has stretched their light into the infrared range. Its first images, released in 2022, showed galaxies that existed less than 1 billion years after the Big Bang, with a level of detail that stunned the scientific community. Webb is also studying the atmospheres of planets orbiting other stars, looking for chemical signatures that might one day point toward the presence of life elsewhere in the galaxy. It has enough fuel to operate for at least 20 years, and astronomers expect it to produce discoveries that cannot yet be fully anticipated. International Space Station missions. The International Space Station is the largest structure ever assembled in space and the result of one of the most complex international collaborations in history. Construction began in 1998 and involved contributions from the United States, Russia, Europe, Japan, and Canada. Since November 2000, the station has been continuously inhabited, with crews of astronauts and cosmonauts rotating through on missions that typically last around 6 months. The science conducted aboard the station covers an enormous range of subjects, from how the human body changes during long-duration spaceflight, to how flames burn differently in microgravity, to how various materials and biological systems behave without the constant pull of gravity. The medical research is especially important because before humanity can send humans to Mars, scientists need to understand and solve the physical problems that extended time in space creates, including bone density loss, muscle weakening, and the effects of radiation exposure. The station has also served as a testing ground for technologies and operational procedures that will be needed for future deep space exploration. After more than 2 decades of continuous operation, it stands as the most sustained human presence beyond Earth ever achieved.